even and odd signal. Consider these English alphabets. Can you find any common property for all these alphabets? If you draw a line through the center of these alphabets like this, you can see that all these alphabets have vertical symmetry. That is true for all these alphabets. What are these alphabets? A, H, I, M, O, T, U, V, W, X and Y. All these alphabets have vertical symmetry. So what is my vertical symmetry? If we rotate these alphabets horizontally or flip the alphabets horizontally with respect to this vertical axis, the shape of these alphabets will remain same. Otherwise we will get the same alphabets. That's why we say that these alphabets have vertical symmetry. So these are the numbers which have vertical symmetry. Similarly, we can draw some vertical axis like this, and if we horizontally flip these numbers with respect to this vertical axis, you can see that the shape of the numbers will not change. Similarly, some shapes like this, a square, a star or an arrow or a triangle, all will have this kind of vertical symmetry. What is the basic idea of vertical symmetry? We draw a vertical axis, and if we flip these shapes with respect to this vertical axis, the shape must remain same. Then we will say that there is a vertical symmetry. So that is the basic idea of even signal. So if you understood that, then the idea of even signal will be easy. If the shape of the signal does not change, so this word is very important. If the shape of the signal does not change in the folding operation. So what is my folding operation? This horizontal flipping, actually the horizontal flipping with respect to the vertical axis, right? So this is known as folding operation. Since the axis we consider is a time axis, we call it as time reversal operation. So the folding operation, otherwise horizontal flipping, in the case of signals is known as time reversal operation. And if the shape of the signal does not change in this particular operation, that is the folding operation or time reversal operation, then that signal is known as even signal. Otherwise we can say that even signals have vertical symmetry. For example, consider this particular signal. Here we have x of t in the y-axis and t in the x-axis. If we flip this signal with respect to the y-axis, or we say that reflection about the y-axis, then if the shape of the signal remains same, then such signals are known as even signal. Since we are flipping the signal, we will denote it as x of minus t, because we are reversing the time axis. If the actual signal and the time reverse signal are equal, then we can say that it is an even signal. So the mathematical condition is a signal is even signal if x of et is equal to x of e minus t. So this e represent this is an even signal. So if x of t and the time reverse signal x e of minus t are equal, then we say that they are even signal. Consider the cosine signal shown here, right? Let us say this is cos omega t. Here this is an example of a even signal. Why it is an even signal? If we flip it horizontally with respect to the y-axis, we will get the same signal. Let us try flipping this signal in this PowerPoint. So what I will do is that I will select the signal and I will go to picture format, and then I will select rotation, right? And I will select flip horizontal. So you can see that even after flipping horizontally, it remains the same. Once again I can flip it horizontal, we will get the signal back, right? So the horizontal flipping does not affect the signal's shape. Even signals have same values at instance t and minus t for all t. So this is very, very important point. For example, let us say that this is 10th second. So if you take the value, maybe this is 2 volt, and if you go to the minus time axis and you reach here, that is minus 10 seconds. This is plus 10 second and this is minus 10 second. And if you take the value, you can see that they are equal. Here also you will get 2 volt. Time is positive or time is negative. If you are taking the same time values, then the signal values will be equal. That is the meaning of this particular sentence. Even signals has same values. See, has same values at time instances t and minus t. Because of that reason, we can write xe of t is equal to xe of minus t. What is mean by that? The signal values, actually this represents the signal value, okay. So signal value at tth instant is equal to, this is also signal value, signal value at minus tth time instant. So this is the basic idea of even signal. So even signals remains unchanged in the time reversal operation, right? So even signals remains unchanged, its shape does not change in the time reversal operation. Now consider this alphabet, English alphabet N, and what happen if I flip it horizontally? That is with respect to the vertical axis. You can see that we will get the letter like this. So if I flip the alphabet N horizontally with respect to the vertical axis, we will get the letter like this. You can see that they are not equal, right? They are not equal. So we can say that the alphabet N is not an example of an even signal, right? If the signal is looking like alphabet N, then that is not an example of an even signal. But what happens if I flip it vertically with respect to a horizontal axis? Here you can see there is a horizontal axis. What happens if I flip this alphabet with respect to the horizontal axis? So let us do that. So if I do that, you can see that I will get the actual letter back. See, the actual letter or actual alphabet N back. I have performed two operations. One is flipping horizontally with respect to the vertical axis, that is done here, and flipping vertically with respect to the horizontal axis. After these two operations, I will get the same alphabet back. This is the shape of the letter after horizontal flipping, and this is the shape of the letter after vertical flipping. So if I can get the original signal or original shape back after these two operations, horizontal and vertical flipping, then we can say that there is a vertical anti-symmetry for this particular alphabet. Okay, so here the signal is having a vertical anti-symmetry. Okay, why? Because see, this is going upwards, but here it is going downwards. Here it is going downwards, here it is going upwards, right? So because of that reason, we can say that there is a vertical anti-symmetry. That is the basic idea of odd signal. If the shape of the signal does not change after, here also does not change, please keep it in mind, the shape of the signal does not change after two operations. One is folding operation. What is my folding operation? Flipping with respect to the vertical axis, or here it is with respect to the y axis, or also known as time reversal operation. Otherwise it is known as time reversal operation because we are doing this with respect to the time axis. The horizontal flipping is happening with respect to time axis. And amplitude reversal, we have to perform a second operation which is known as amplitude reversal, right? What is my amplitude reversal? We are flipping the signal vertically with respect to a horizontal axis, right? And then if you get back the original signal, we say that the signal is an odd signal, and we can say that the signal have vertical anti-symmetry. So look here, this is our actual signal, this signal is almost similar to the English alphabet N, and this is actual signal x of t. And first what I am going to do is the time reversal, then I will get the signal like this. So this is the outcome of the first operation, time reversal. Now you can see that if you compare these two, they are not equal. I am going to do another operation, that is amplitude reversal. What is my amplitude reversal? I am going to multiply this part with -1, right? -1 into this part. So what happened? It will become positive. Already it is negative, and I am multiplying with -1, so it will go into positive, right? So all this part will go to positive. So I will get this part as positive, and here I will again multiply this part with the -1. So what happened? Already it is positive. Since I am multiplying with -1, it will go to negative. The same will happen here also. This part also I will multiply with the -1. Since it is positive, it will go downwards and it will be like this. So if you compare the first signal x of t, okay, you can see that we got the original signal back after these two operations of time reversal and amplitude reversal. Since I have first time reversed, my intermediate signal will be equal to x of minus t, right? X of minus t, because I have performed the time reversal operation. I have flipped the time axis. So because of that reason, it is denoted as x of minus t. Since to get back the original shape, I had to multiply with -1, I have to write it as minus of x of minus t. Minus of x of minus t. Actually, this signal is minus of x of minus t. I have performed two operations. The first operation is nothing but time reversal. So this minus is because of time reversal, and this minus is because of amplitude reversal. Amplitude reversal. We can say that if this condition is satisfied, that is x o of t. Why it is o of t? This o indicates this is an odd signal. X o of t is equal to minus of x o of minus t. Okay, then that signal is an odd signal. So here two operations need to be performed. This is time reversal and this is amplitude reversal. Okay, if we get back the original signal after these two operations of time reversal and amplitude reversal, then we say that such signals have vertical antisymmetry, and we call such signals as odd signals. I hope you got the idea about odd signal. Now consider an odd signal sine omega t. Okay, sine omega t is an example of an odd signal, right? Here you can see this is going upwards and this is going downwards. This is going downwards, at the same time it is going upwards, right? Here it is going upwards, but here it is going downwards. So there is a vertical antisymmetry. Since there is a vertical antisymmetry, we can say that the signal is an odd signal. So here the value of an odd signal at time instant t is a negative of the value of the signal at time instant minus. What is the meaning of that? So consider this is 10th second. This is 10th second. If I take the value of the signal at 10th second, I will get something around 2 volt here. But if I go to the negative axis and if I reach minus 10 second, okay, minus 10 second, if I select the value at that particular instant, I can see that it is minus 2 volt. It is minus 2 volt. It is 2 volt. This is minus 2 volt, right? So we can write x o of t is equal to minus of x o of minus t. Now consider the discrete time counterpart of the even signal and the odd signal. There is no much difference. Only thing is t is replaced with n, and instead of curved bracket we will use a square bracket to represent the discrete time signal.